Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about determinant of interest rates. In this lesson, I'm going to show you how to quote the interest rates for the Treasury bills and how to evaluate the interest rates under some situation in which inflation and default risk are involved. So let's get started off with the U.S. Treasury bills. For the U.S. Treasury bills, the interest rate is quoted by the formula 360 over the number of days times the dollar amount of interest over the maturity value of the Treasury bill. For convenience, we notate D as the quoted rate, C is the maturity date, P is the price as issue, and the difference between C and P is the amount of interest earned. N is the number of days from issue to maturity. So D is 360 over N times C minus P over C. And we can derive for P. P is 1 minus ND over 360, the whole thing times C. For Canada Treasury bills, there's a little bit difference. For Canada Treasury bills, we are going to use 365 instead of 360, and the amount of interest will be divided by the price at issue instead of the maturity value of Treasury bills. We use almost the same notation, only the quoted rate in Canada Treasury bills is notated as I. So I is 365 over N times C minus P over B. And the price, P is equal to C over 1 plus N over 365 times I. So that's how the interest rate under the Treasury bills are quoted. Now we consider the interest rates when default risk exists. There are two types of defaults. Defaults without recovery and default with recovery. For the defaults without recovery, let's say X is the amount received with no default and Y be the amount with default of rate Q. There is a relation between X and Y. X is equal to 1 minus Q times Y. And default with recovery, let X be the amount received with no default and Y be the amount with a default of rate Q and with a partial recovery rate U. Then 1 minus Q times Y plus Q times UY is equal to X. And when default risk does exist, we need a method to evaluate the interest, that is the components of interest rates. Here, let R be the interest rate without default risk, S be the rates for risk compensation, and I be the inflation rate. The first situation is when there is default risk but no inflation rate. So for the effective interest rates, the component is R is equal to 1 plus little r times 1 plus little s minus 1. And for the interest compounded continuously, the force of interest rate R is equal to little r plus s if R and s are both the continuous interest rate of default risk and risk compensation. In the case that default risk exists and inflation exists, and the inflation is known, then the effective interest rate is capital R is equal to 1 plus little r times 1 plus little s times 1 plus I minus 1. And the component of force of interest rates, R is equal to little r plus s plus I. In the case that default risk exists but uncertain inflation, we do not consider the effective interest rate. We only consider the continuous interest rate. That means the force of interest rate. So R is little r plus A plus IE plus IU. Here IE and IU are the continuous expected and unexpected inflation rates. So that's everything for today. Now let's try to do some practice. Question 1. A lender requires an annual effective interest rate of R is 4% without default risk, and an annual effective interest rate of R with default risk. Find the compensation S of default risk. So just follow the formulas. 1 plus R is equal to 1 plus little r times 1 plus little s. Capital R is the interest rate, the effective interest rate with default risk. Little r is the effective interest rate without default risk, and S is the compensation rate. So S is 1 plus capital R over 1 plus R, the whole thing subtract 1. So S is around 1.21%. Question 2. Consider a group of 500 people, each of whom is interested in borrowing a loan of $6,000 for 2 years. The lender requires an annual effective interest rate of 4%, assuming there would be no default. Find the annual effective interest rate the lender should offer if it is expected that 13 borrowers from this group will default. So here the question gives you the interest rate without default and the interest rate with default. So remember, X is equal to 1 minus Q times Y. X is the amount received if there is no default. So here a loan of 6,000 in 2 years, and the effective interest rate without default is 4%. So X should be 6,000 times 1.04 square. Y is the amount received if there is default. So Y is 6,000 times 1 plus I squared. Suppose I is the interest rate with default, effective interest rate with default. And Q is the default rate. So it's basically the number of people who default over the total people. So Q is 13 over 500. Now we apply the formula X times X equal to Y times 1 minus Q. 6,000 cancel with 6,000, so we have an equation 1.04 squared is equal to 1 minus 13 over 500 times 1 plus I whole square. So I is around 5.38%. Question 3. How much should be invested today at an annual effective interest rate of 5% to provide for a 9-year annuity with a first payment of $930 in 3 years at t is equal to 3, and subsequent annual payments are indexed to reflect an inflation rate of 2%. So here the first payment is $930. Occurs in at time 3. The next payment, the second payment, will appear at time 4, and the second payment should be 930 times 1.02 because the inflation rate is 2%. At time 5, the third payment of 930 times 1.02 square will be implemented. So let's say V is 1.05 to the negative 1. We got the present value of this annuity is 930V plus 930 times 1.02 V squared plus 930 times 1.02 square V cubed plus dot dot to 930 times 1.02 to the 8 V to the 9. So the present value is, if you factor 930V outside, this is a geometric series. So the first term is 930V. Then 1 minus the ratio to the n over 1 minus the ratio. So the amount should be invested today is around $6,457. Question 4. A Government of Canada Treasury bill maturing for $100 is bought at a price of 98.41 at a quoted rate of 7% annually for the term of this T-bill. So in this question, this is Canada Treasury bill, so we are going to use 365 instead of 360. 100 is C, P is 98.41, 7% is I, and the question asks for N. So remember I, the quoted rate is 365 over N times C minus P over P. So N is 365 over I times C minus P over P, and we substitute I as 0.07, C as 100, and P as 98.41. The answer for the number of days should be 84.25, so around 84 days. Question 5. Consider a group of 300 people interested in borrowing a loan of $7,000 for 6 years. The lender requires an annual effective interest rate of 4%. Assume there would be no default and an annual effective interest rates of 5.58% if it is known in advance that N borrowers from this group will default. Find N. So in this question, they give us enough information to calculate X, the amount received with no default, and the amount received with default, but they didn't give us the default rate. So what we have to do is find the default rate. Here, the amount received without default is X equal to 7,000 times 1.04 to the 6, because 7,000 is the amount of the loan. The length of the loan is 6 years, and the effective interest rate is 4%, assuming no default. The amount received with default is Y is equal to 7 times 1.0558 to the 6, because 7,000 is the amount of the loan, 6 is the length of 6 years is the length of the loan, and the effective interest rate with default is 5.58%. So we got and the default rate is Q is equal to N over 300. The default rate is the number of people who will default over the total number of people. So use the equation X equal to Y times 1 minus Q. We got 7 times 1.04 to the 6 equals to 7 times 1.00558 to the 6 times 1 minus N over 300. So N is around 25.94, around 26 borrowers. So among these 300 people, around 26 will default. That means they will fail to pay off the loan, fail to return the debt, to pay off the debt. Question 6. Which of the following statements about interest rates are true? First statement. An interest rate can be decomposed into components where its component viewed as a compensation for a particular risk. So this question is right. Right at the definition of the components of interest rate, we can decompose them into the factors, right? So I is correct. The second statement, interest rates can differ greatly from one product to another. Yes, because from one product to another, not only the price of the product changes, also the default rates also change. So the interest rate can be differ greatly from one product to another. Interest rate, so second statement is true. The third statement, interest rates can differ greatly from one borrower to another. Yes, because the default rates of different people are different. Like for rich people, the probability that they default is lower than poor people. So the solution is all of them are correct. are true. Question number 7. The following two investments are available. First investment, a 26-week U.S. Treasury bill maturing for $10,000 sold at a quoted rate of 7.23% annually. The second investment, a zero coupon bond paying $55,000 at the end of 14 years with an effective annual yield rate of 5%. If both investments have the same purchase price P, calculate I. So first we find the price of the U.S. Treasury bill. So this is a U.S. Treasury bill, so we use 360. P is 1 minus ND over 360, the whole thing times C. And we use 26 weeks, 26 times 7, 882 days. So 182 substitute into N. D is 0.0723 because the quoted rate is 7.23% annually. So the price for the 26-week U.S. Treasury bill is $9,634. The second investment is a bond with zero coupon, and there's redemption value of $55,000 at the end of 14 years. So the present value of this bond, the price of this bond is just $55,000 times 1 plus I to the negative 14. Suppose I is the yield rate of this investment. And since both investments have the same purchase price, so we can set this equal to 9634 and solve for I. So I is around 13.25%. So that is everything for today. Thank you so much for watching my video. I hope you guys enjoyed my video, and I hope it's useful for you to practice for exam FM. See you next time. Bye.